Welcome everyone to Current Affairs by Civils 360 IAS Academy. So in this session we will be discussing about the crude oil distillation process by which the various components of crude oil is actually separated out. Right, and we will be focusing on liquefied petroleum gas LPG because LPG is in news because of the supply disruptions, large import dependency of India on LPG, and the rationing of LPG to both the individual consumers, households, as well as the commercial users. So we will first start with the process of how the crude oil is actually from crude oil. How do you actually get the different products? Right, from bitumen, from diesel to petrol to LPG and all. Okay, so basically the process is what we call as the fractional distillation. Okay, this is what we call as the atmospheric tower. Okay, it's a technical term. It's an atmospheric tower where this distillation actually happens. So you have crude oil. The first step is actually to vaporize the crude oil. Okay, so it is the vaporized crude oil that is actually fed into the atmospheric tower. So it is at a very high temperature. Now the distillation is based upon the fact that the different components of crude oil has different boiling points. Okay, so what is the idea of a boiling point? Okay, so at that temperature, okay, at the boiling point they will become liquid. Right, whatever substance we are talking about, at their boiling point they will be a liquid. So if you go below, if you increase the temperature above the boiling point, they will become a gas. Okay, so this is the boiling point temperature. Okay, this is the boiling point temperature. If you increase the temperature beyond that, they will become a gas. If you reduce the temperature below this boiling point temperature, they will be a liquid. Right, so that is the basic idea. Right, so it's a very simple idea, but don't get confused. So because the different components of crude oil has different boiling points, they will liquefy at different temperatures. So as you go up the atmospheric tower, there is temperature. If you look at the temperature of the atmospheric tower, it will be low at the top and high at the bottom. Right, at the atmospheric tower, you can see that the high temperature is at the bottom and the temperature at the top is lower. Right, so when the vaporized crude oil is actually passing through this tower, right, at the top we can see that those substances with a lower boiling point is seen, because all the other products will be liquefied at a higher temperature. Right, so at the top only those products that has a lower boiling point is seen. I hope the idea is clear. Okay, so you can see LPG here, because LPG consists of mainly propane and butane. We will see that they have a low boiling point. Low boiling point, and those at the bottom has high boiling point. Okay, so please remember, if you look at here, you can see petrol here and diesel here. So petrol has a lower boiling point than diesel. That's an important point. Just keep that in mind. So let's just take the atmosphere. Okay, so the crude oil vaporized gas, it is going. So at these temperatures, you can see the temperature here, 350 degrees Celsius. Okay, at these temperatures, say LPG, okay, you take the case of LPG, say mostly it is usually a range of temperatures. When we say the boiling point is, it's not like a fixed temperature, it would be a range of temperatures. But just for convenience, say the liquid petroleum gas, because it has propane and butane, they both have different boiling points. But say on average, say it is it's given here 25 degrees, so say it is 20 degrees Celsius. Okay, 20 degrees Celsius is actually the boiling point of liquid petroleum gas, which means only at that temperature, okay, will they become liquefied. Only at that temperature will they be liquefied. So since the temperature, so their boiling point is 20 degrees Celsius. So only when the temperature actually goes below 20 degrees Celsius will they be liquefied. So if you take the vaporized crude oil, here there is 350 degrees Celsius. Okay, they won't be liquefied because the temperature is above 20 degrees Celsius. So here also they won't be liquefied, here also they won't be liquefied, right? They only will, if there's any chance of any liquefaction, they will only get liquefied here. Right, so that's the basic idea of fractional distillation. Again, take the case of say diesel. Okay, say diesel has a boiling point of 225 degrees Celsius. Okay, 225 degrees Celsius, diesel's boiling point. So at this temperatures, okay, the temperature is higher, it will be still be in the gaseous form. It will not get liquefied here. It will not get liquefied here. It will only get liquefied in these areas when the temperature is actually below the boiling point. Okay, below 225 degrees Celsius. Only at that temperature will diesel also get liquefied. So please remember, these products has liquid petroleum gas, petrol, naphtha, paraffin, which is used in aircrafts, they have a lower boiling point. Okay, these products have a lower boiling point. These has higher boiling points. Okay, so afterwards, again, what happens is that they actually do vacuum distillation as well, which is basically they will again do the same process in vacuum, right? And then the heavier substances will also get separated. Okay, so just understand the basic idea. So if you look at this, was the basic idea. In the top you can see those with the lower boiling points, right? Gases, naphtha, petrol. Middle you can see those with intermediate boiling points like kerosene, diesel, right? At higher boiling point you can see residual fuel oil and heavy residue. Now if you look at LPG is actually consisting of propane and butane. Right. So if you look at natural gas, it consists of methane and ethane. So LPG is more heavier than natural gas. That's a key point. It is more heavier than natural gas. So since it is heavier, whenever there is a leak, the LPG will be settling down at the lower layers of the air. Right, which causes safety risk because they are obviously inflammable. They will easily combine with oxygen to release heat. So since they are heavier, they won't disperse easily. But natural gas, since it consists of methane and ethane, they are lighter, they can get easily dispersed. So compared on safety, LPG is not that safe as natural gas. LPG also, if you look carefully, it's actually a mixture of several gases like propane and butane. So butane is actually it consists of 4 carbon atoms, right? 4 carbon atoms, and propane consists of 3 carbon atoms. Okay, just keep that information as well. So it is used in various purposes that you know. It is also used as a refrigerant to replace chlorofluorocarbons, which have been phased out thanks to the Montreal Protocol, but it is now being used as a refrigerant to replace that because it does not actually harm the ozone. Right, and it has a higher calorific value than natural gas. That is also important. It has a higher calorific value. The amount of energy it produces when you burn 1 unit of that fuel is higher. Right. So if you look at the import dependence, India imports about 60% of our domestic demand of LPG. Okay, LPG, the domestic demand, 60% is actually met by imports and 90% actually comes from the Strait of Hormuz. So it causes a supply disruption in case it is, but same kind of import dependency is there for natural gas, but from the Strait of Hormuz only 30% actually comes. Okay, so compared to LPG, the natural gas has less of a supply disruption, but still same level of import dependency is there. Okay, just that supply disruption due to the closing of Strait of Hormuz is less for natural gas. That is why the government is actually supporting the piped natural gas. But piped natural gas are not available in rural areas, right? Only in selected urban areas. Okay, so safety aspect we discussed. So another alternative that people have been talking about is actually the dimethyl ether technology, which was developed by CSIR with their National Chemical Laboratories of Pune. Okay, so basically DME is actually can be blended with LPG to reduce the amount of LPG. Okay, similar to how you blend ethanol in petrol, you blend dimethyl ether with LPG, right? So when they blend, you need less quantity of LPG to produce the same quantity of fuel. The dimethyl ether is actually sourced from methanol, coal, as well as captured carbon dioxide. So the CSIR, they have came up with this technology, and it can easily be done. The dimethyl ether can easily be fueled into the LPG, so there is no need for changing the stove or changing the cylinder. Okay, there is no need to change the pressurized cylinder or how it is to be, or even the stove also does not need to be changed. Right, so that is one of the alternative that has been proposed. It has just been proposed recently. So keep those kind of ideas also in mind. Okay, so that's all in this session. So in this session, we saw about crude oil, we saw the distillation, how that happens, that boiling point idea. Then we discussed about LPG and how it's slightly different from natural gas. We looked at one alternative that has been used, dimethyl ether technology. So that's all in this session. Thank you.